Hi all and welcome back. So in this video we're going to look at how to apply some of the stuff that we've seen in the previous videos and really look at what's best practice when it comes to working drawing, or how to, I suppose, expertly dimension a piece that you have. So we'll be applying, I suppose, the rules that we've seen and really kind of going through the decision making process to what dimensions to apply to a particular piece. Let's just talk about kind of good dimensioning first of all and great dimensioning. So like you can have all the dimensions that you require on a drawing, and it's a perfectly functional drawing and it's a good drawing. But in order to make it a great drawing, I suppose really what makes the difference is how usable or readable the drawing is. That when you hand the drawing to someone, that they're able to kind of work with the drawing as easy as possible. When they're looking for a dimension, it's very plainly obvious where that dimension actually is in the drawing. So the best working drawings are the ones where the dimensions are indicated in a way that makes them easier to follow for the user. So an example of that is, what dimensions do they need for manufacturing? Is there an order to what dimensions they might need? Are they working from a reference line constantly? If so, dimension it from a reference line. So tip one, try to give the dimensions of the piece in a way most useful to the reader. And probably the best way to do that is, or to show this, is just with a little simple example. If we take, for example, here a piece of skirting board. So it's just a square piece, a rectangular piece of timber with a small little chamfer planed off the edge of it. So here we have just four different ways that could be dimensioned. Every single one of these gives all the dimensions for the piece. Each of these could be considered technically correct. But let's just look at the first example here, and we'll see what we're talking about. Here we have our piece here, and like the process for this is, you want to take your section of timber. So it's going to be a rectangular section, and you're going to plane off your chamfer here. So the first thing you're going to need to know is, well, what size of the actual rectangular section do you need? And if you look at the way the dimensions are given here, 130 and 20, in order for me to know the height of the piece, I have to add the two of these together. Same way for the width, I have to add 20 and 20. Now, that's not necessarily a super difficult thing to do, but if this was a long chain here with a lot of dimensions on it, all of a sudden you're making the person who's going to make this have to add up all these dimensions, and they're more likely to make a mistake. So even though it's correct, it's not the best possible. So if we look at the second example here we can see we've added in 150 and we've added in our 40. So when I take my stock and I pull out the actual sections that are required, I know I'm looking for 150 by 40. But is this the best way we could do it? Well, if we look at the way we dimensioned the chamfer here, I've dimensioned it 130 and 20. I've actually dimensioned it by the space left over after it's been planed. And maybe that is important to you, but in this case here, that's not how you would plane a chamfer. You don't say take off a chamfer so that you have 130 and 20 left over in the piece. Um, you dimension it more like what we have here, where you'd say 20 by 20. I'm taking a 20 by 20 chamfer. So, I mean, this is much kind of better, particularly if you're using a hand plane to plane off your chamfer. You'll be able to set your marking gauge to 20 millimeters and 20 millimeters and mark the piece and then plane it down. So this will be better than what we have here because it's more useful to the person. They don't have to go subtract 130 from 150. But is that the best way? Well, if you were planing it by hand, it is the best way. But if you were going using, say, a machine, it might not be the best way. And we'll give you the example of that. So here we just look at a video of the actual process. So if we put it on a spindle molder, you can see we are planing off the actual edge of our piece like that. So we have a tool bit that's going to basically spin like that, and we run our piece through it. So when it comes to processing that, we're going to need to know two things. We need to know what angle of the actual bit I need to choose or select, and I need to know the depth of that piece. So if we look at this fourth weight, here we can see exactly that. We've given the same thing as with our 20 by 20, but this time we've said it's 45 and in 20. So the depth here is 20 and the angle here is 45. So you know which bit you're going to pick, you know which angle you're going to have. And that's particularly important if you had, say, something that was maybe, 45 is not too bad because 20 by 20 it wouldn't be too difficult to work out. But if it was a different angle or a 30-degree angle, that may not be apparent from your actual distances here like that. You would actually need to specify the angle for it. So again, going, each one of those perfectly correct, but one of them here is the most useful. It's giving the manufacturer the information as they need it. So you mean when we look at this, you can see 100 by 40, that's the piece of timber I take out. I'm going to set my depth to 20, I'm going to pick out the 45-degree router bit. So let's just take a couple of examples of where that comes into play. So tip one, again, try to give the dimensions to the piece in the most useful way possible. So here we have a small little plate like so, and I've just dimensioned that. So that's fully dimensioned there. And you can see we have a hole through the middle of our piece here. And you can see I've dimensioned that in the most useful way for the reader. I've given the diameter of the hole. Like, why didn't I give the radius of the actual hole? Well, the simple reason is when you go to actually drill that out, you're going to be picking your drill bit by its diameter. If I give the radius of that, you run the risk of someone potentially picking out the wrong drill bit. If I'm looking for a diameter 30, I find the drill bit with 30 millimeters written on it. It's as simple as that. It's also the same there for the radius here for the corners. Why have I given radius here? Well, if I'm marking that out, I'm going to mark it out with a compass. So I'm going to set the compass to the radius. Equally, if I'm going to mark the center point or to find for my punch, I'm going to need to set come in my 10 mil and my 10 mil. So that's the figure that I need there for that. If I give the diameter for that circle, well, all of a sudden I'm making the person have to stop, think about it, and that's where mistakes tend to get made. That's where you end up with kind of corners here twice as large as what you actually want. You'll also see we have a 4 by there and things. So I haven't dimensioned every single corner here, but instead I've put a 4 and a little multiplied symbol by the radius 10. So that there tells the actual reader of the drawing that all 4 of these are the same. If we didn't have that there, we'd be working on the assumption that they're all the same. And again, a drawing shouldn't be making the person make assumptions. It should be telling them very, very explicitly. If it's, and if a good drawing, that's exactly what a good drawing does. You can also see, going back to the idea of the overall size of our piece, here we have 80 by 80, so we know the original plate that we're going to be cutting out is going to be 80 by 80. You could give that dimension like a chain dimension here like so, and make the reader add them all up. And you can see I haven't given the radius here, I've seen it written as 10, which isn't as obvious as my actual radius 10. So again, these 3 chain dimensions here do actually work, it is correct, but it's not as easy to read. And if all these here don't add up to 80 millimeters, all of a sudden we've got a conflicting dimension, and that can sometimes happen. Sometimes you might go back and decide that you wanted 100 by 100, and you might just change this dimension here, maybe in CAD or by hand. And if you forget to update these, well, all of a sudden the reader doesn't know which one is true. Is it 100 or is it going to be the original 80, these adding up? So, that's something you really want to avoid, is conflicting dimensions, over dimensioning something. So we always say just dimension something once and once only, and dimension it in the most obvious way. Just taking with this example, or sticking with this example here, we can see there's our kind of back to where we were. We say that always try and dimension the contour of the features. That's tip number 2. So when we say the contour of the feature, we're talking about dimension the view where you see the shape of the actual feature you're talking about. And if we stick with the actual hole here like that, it's the plan view in this case that we can see this is where the hole actually is. It's a diameter 30, the dimension goes where we see the circular part of the hole. The hole here is represented up here with hidden detail, but it's not as obvious from the hidden detail that that is actually a hole. There is a center line, but again, it's not as obvious. You could dimension that, and it would be perfectly correct. We still have our diameter 30 to indicate that they would be a circular hole, but when you look at the drawing, this is the view you look at when you see the hole. You don't look up here. And if you do dimension it up here rather than here, you're making the reader look around the page for something. And again, that's going to make the drawing kind of a pain to work with. If we follow that same idea on with our, say, the overall size of the piece, we have our 80 by 80. This is where we see the square shape, or the original square shape of our piece. You could go and use a similar dimension in your elevation there. I've put a little square symbol there, which is technically correct. That means this piece is square size 80. And we can see it's 80 across the width, but that square there would indicate that it's also 80 across the depth. And that's technically correct, perfect, no bother at all with it, but we don't see the depth there, so it's not where we look when it comes to finding the overall shape of the plate. So even though it's correct, it's not the most useful. And you could go one step further and kind of go and say, well, look, we could dimension the radius 10 there like that for the actual fillets in the corner, but now you're really kind of getting silly. Like that's really, really kind of, that's hard to read now. So like these dimensions up here do the same as the ones down here, but way, way more difficult to read. And again, that's where kind of common sense has to kind of prevail with it. Make the drawing as easy to read, dimension the drawing where you see the shape of the object. We have one other tip then as well, which is to try and indicate as much information graphically as possible. And there is one thing that isn't mentioned on this, which is the center of this circle here. At the moment, we are assuming that it is centered on the piece. It may or it may not be. And now you could go and put some dimensions there to indicate that it is in the middle. Or what you could do is you could take these center lines here and extend them out past the size of the object. So anyone reading that drawing would know that those lines there should only stop just outside the actual feature. The only reason they would have to be extended out like that would be if they're actually indicating that it's centered on the piece. And in fact, you can actually go and draw two little dash marks here, and then across here and the top here, that indicating that it is the dead center of the piece. And now what you're doing is you're saying it explicitly. You're not making the person assume that it's centered, because if they're assuming it, that means that you haven't told them, which means you've fallen down in your drawing. And if a mistake is made, well, it's not their fault. They're just working with what you've given them. So that's I suppose, the responsibility of the person creating the drawing. Let's look at another example. So again, going back to the kind of the bench room, here is an example of a haunched mortise and tenon joint. So here we see again a good example and a great example. So if we look at our object here, just going back to again what we were saying about, say, give the information as the user uses the information. So we were going to start off making this here. The first thing I'm going to want to know is what's the size of the actual timber I'm going to be processing. And again, looking here like that, here we have a whole series of pieces added up together like that. So you mean 10, 15 like that. Not very useful. Same thing applies when it comes to the likes of the haunch. When I look at the haunch here like that, or say for the mortise, pardon me, um, here's the contour of the mortise. This is where I see the mortise. You know, I mean, I have that information on this drawing, 10, 15, and then 10 here, but it's not useful to me. This is where I see the shape of the mortise, so this is where I'm looking. You're now making me run around the drawing trying to find those dimensions. So now I'm going to get frustrated with the drawings. Whereas over here we can see the actual dimensions there are given, where we see the contour of it. If we take these dimensions here and just maybe move them up here, here I've given chain dimensioning, like so. So chain dimensioning versus our datum dimensioning. You can see these are one after the other, where these ones each come back to a single reference point. Which is better, which is best there? Well, it depends on how you manufacture the piece. So if we look at, say, how we would actually go and cut out that mortise, we'd either use a chisel, or we could mark the depth on our chisel like that. So when that tape there hits our top face here, we know we're at the correct depth. Or if we were using, say, the likes of a mortising machine, we'd use our auger here like that. And again, we will set the depth stop off our top surface. So in this case here, the best possible way to dimension that is using our datum dimensioning, because that's how we will actually manufacture the piece. So that's kind of good, but this is great. And we can see again a couple of other examples where we're kind of breaking rules with it. If we look at, say, the overall height of our piece, here we can see we have our chain dimensioning here, and there's a mistake made that the overall height here is 450, but you can see there was a mistake made here on this dimension. All of a sudden, if I'm trying to make this, I actually don't know which is which. I don't know, do I trust this 450 or do I trust this 450? And this is where our conflicting dimensions come into play. A lot of the time in, say, Inventor or Fusion or SolidWorks, these things will be taken care of because there'll be a certain amount of them automated. But if you're doing it through CAD, you may be putting them on yourself, or sometimes you might have to adjust something, and like mistakes can get made. So in this case here, you're better off eliminating him. Now we've got our chain dimensioning here for our mortise. Here we have our datum dimensioning. In this case here, which is better? You could actually argue for both here like that. It's actually not that, each one is perfectly good. It's nice to be able to use a reference point like that, but if this distance got too far, larger than, say, a typical ruler, well, you'd prefer to use your chain dimensioning to mark the piece. So you could argue either way. In this case now, both are perfectly correct. But before we're actually finished with this, we'll just have a look down here into our plan, and we'll look at the actual plan of the mortise. So I think we can all agree that giving the dimensions like this is a very poor way here. Like here we have the actual length of the piece here like that, or the width of the piece indicated up here in our elevation, and you're making the person add them all up together. So I look to my plan, but I have to go back up to my elevation to find what the width is, and I have to do a bit of maths to figure it out. You can see here in our plan view, 12.5, 10, 12.5. Again, I have to do my maths. Whereas really we just want to indicate as clearly and cleanly as possible, we take a 35 by 35 piece. If we look at this here as well, our 12.5, I've given my three dimensions here, but which one is the most important? In actual fact, if I was going to actually use my mortise machine here, or if I was going to use my actual chisel, what I need to know is, well, what size chisel am I picking out here? So if I have my auger here, I'm going to need a 10 mil one. So the 10 mil one is the key dimension there. And with my 12.5, really what I'm saying is that this needs to be centered on the piece. And if it's important that it is centered on the piece, um, you're likely to make a mistake here. Like often in the case, the computer will round this up to 13 and 13. If that was the case here, you'd have 13, 10, and 13. So this will add up here to 36, and then we'd be indicating that the overall size is 35. Now we've got a problem. Who knows which one is the correct one? Whereas if we look at the way we've dimensioned it here in this great example, well, we haven't given a measurement, we've given the overall measurement, and by putting these two little strike lines here, we're indicating that the 10 here, it's important that that 10 is centered on the piece. So if I was manufacturing that, what would I do? I'd probably cross the diagonals, I'd locate the center, square it out, and then mark my 5 by 5 and 5. So you've given the actual person making it, a kind of a clue of what's the most important aspect of it. It's most important that that is going to be centered on the piece. If it was more important that mortise there was going to be maybe a specific measurement here, so if it was going to be a particular measurement at the front here, well, that's the measurement you give, and you wouldn't give this other dimension here like that. So it all depends on what's important to you. Working with kind of a couple more examples, we'll just kind of run through, say, just some kind of very basic orthographic pieces here like that. So we have the elevation and plan of 4 pieces, and we'll just talk through the actual dimensioning of them here, just to kind of give you this idea of how you go about dimensioning or what's important with it. So one of the useful kind of tips I find when it comes to figuring out where to dimension or what aspect of dimension is, how would you describe the piece? So if I look at this piece here, here's my elevation plan. I would describe that as a rectangular piece. So I start off with a rectangular piece, I take a rebate off of it, and I take a chamfer off the bottom here. So the important information for me is, well, what is the overall size that I start with? So in this case here, it's 75 by 55 height. That's my original rectangle. And I'm going to take a 45 by 25 rebate out of that. You can see here I've given my dimension here for my chamfer. I've given 20 millimeters depth or height here like that. I haven't given the distance in here for the bottom because technically I don't need to, because I already have that dimension, because I don't have any other hidden lines there like that. So that indicates at that point it should be directly below here. But in that case there, if you're reading the drawing, that takes a bit of working out. So you might actually be better off giving in the 30 millimeters there like that. You are technically, that is kind of doubling up on something, but you are making the drawing much, much easier to read. So again, common sense should always kind of prevail there. And we've given our depth here in our plan view. That's the only dimension I need in the plan view. So I've really made it easier for the person to create. They don't need to go down to this back, up and back, up and back between their views. They just use this view for the depth. Let's look at the same idea here with a very similar piece, only this time it's sloping in. Again, we have our hidden details, finishing off, making sure you have all your hidden lines, and that's the way you're going to approach each of your pieces, drawing your finished lines, then add your hidden lines, and then add any center lines you might need. So again, the original starting point will be an 80 by 45 rectangle. Now we're going to take a 30 by 20 rebate out of it and a 40 by 20 chamfer off the top of it. And then we have the overall tapering going from 40 millimeters to 20 millimeters. And you can see the text placement, everything there perfectly correct. Looking back at this one here then, this example, here we have kind of a piece with a hole through it, a chamfer on it, and a rounded front of it. Well, again, let's put in our hidden details. So there's our hidden lines for our hole. We're going to put in our center mark for both the actual hole and the larger hole here. And tip 3 was that indicate as much as you can through graphical means. In this particular case here, we're saying that the center for this semicircle here is shared with this smaller hole here like that. So it's the same. The two are concentric. They both share the same center point. If we have our center mark in elevation, we will have our center line here in our plan. And they're not connected with each other, and they shouldn't go from one view to the next. They should just go a little bit past the piece. So there's our center lines like that. And here's our dimensions. So again, our chamfer, there's the where we see the chamfer, so we put 15 by 15. We don't need to put the 15 up here. We know that the piece is 25 millimeters wide. We know it's 35 millimeters high. And you can see the hole is given as a diameter 12. Diameter again because that's the diameter 12 mil drill bit that we'll be picking out. I haven't given a radius for the actual semicircle here because the center lines here indicate that it is the same diameter as our 35 here, like so. So that is actually indicated. Now, you mean what might be important to us is the location of this center point here. So I've given that a 60, like so. There is one other dimension which might be useful to someone making this, and it's the overall size of the piece. So if they were picking out a piece of stock, I'm going to cut a piece of stock. Well, what size should it be? So, but all the pieces here is actually fully dimensioned. So anything else could potentially be a conflicting dimension. But I am going to give the overall size of the piece. But just in case that it does conflict with anything else, I'm going to put a bracket around it like so, 77.5. So that is the overall size. But the bracket there indicates that that is a secondary dimension. So that means that if it conflicts with anything else, ignore it. The other dimensions are more important. And where you'd often see that being used will be maybe on a diagonal. If you were making a frame or something like that, um, you might give the diagonal to help the person check it. So you mean obviously if you were making a square frame, people would check the diagonals to make sure that the two diagonals are exactly the same, then they would know it was square. But if you were making a piece that wasn't necessarily square, let's say it was four-sided but maybe tapering or that, you could actually give them the dimension for the diagonal that it should be this measurement when you check it. And that way then you put your brackets on it saying, look, it's not a driving dimension is what we would call it. It's just a checking dimension. So that's that piece there. And then our last piece here again where we have a turned piece here. So it's a kind of a cylindrical piece with a hole going through the middle of it. And then we have a hole going in from the side. So like before, we're going to put our hidden detail for the hole going through the middle. So we can see it goes all the way through the piece. And then we have our hole here going in from the side, again going all the way through the piece. And like before, we have our hidden lines. Now we put our center lines. So the center line for the small hole going all the way through the piece. So that's the same like that. And there's our center mark here for our smaller hole like that. And we do the same here, our center mark for the actual larger circle here like that. And I suppose this here will be also works for the actual center line for the hole going through the piece. So now we put on our dimensions. You can see I've given my diameter for the outer one here, not the radius, but the diameter, because if I wanted to check that, I would measure it with my vernier calipers and it'll be the diameter that I'll be checking. Same thing applies my diameter 20 for the hole because it's the diameter 20 drill bit. Same thing diameter 12 here like that. You can see I'm just giving my overall length there, that's 75, and I've given a dimension here for the hole located like that. So if it was really important that that was 35, and if this was could be a bit longer, if that wasn't the important dimension there, I put my dimension at that. If it's important that that hole here, really important that that is located in the dead center of the piece, well, what I would do is I would put in my two little strikes like that to indicate that it should be centered on it. And if you wanted to do that graphically though, you could actually just put in a center line like that. I would be less inclined to put the center line like this in this case rather than the plate piece, just purely because I suppose when we see it like this, it's obvious that this center line here indicates that this square here is kind of turned. It's not a square, that it is actually kind of cylindrical in shape. So I think if you add the actual center line there, it kind of takes away a little bit from that. And again, that's a judgment thing. It's not incorrect. It is just down to judgment, but I would say that that probably is a bit easier to understand, in this particular case because it's a cylindrical piece. But that's, I mean, I suppose a quick run through on how to apply our dimensioning. And you can see really it comes down to the thought process involved in it. I mean, trying to think about what dimensions does the actual person making this need? What's going to make it easier for them? And like a good working drawing will say an awful lot about the person who's doing it. I mean, and it shows that you've thought about how it's going to be manufactured. And in some ways, when you create your working drawing, it's your first way to go through a piece before you go down to the bench room maybe yourself. A good working drawing, you will hopefully have gotten through a lot of, I suppose, the actual process before ever touching a piece of timber or a piece of metal. So you mean it really is kind of kind of filling in part of the design process. Um, anyway, so that's just, our run down through it. Again, hopefully now, that arms you with enough information to kind of be confident in your own drawings. So yeah, happy drawing, and we'll put up another video where I will go through a full sample working drawing. So I'll take an actual piece and I will go through all the different components and how your actual working drawings should look like when they're finished. So we'll see you then.